Good morning, everyone. Today we're going to continue to talk about how wind is made. And to understand the next step of how wind is made, let's go ahead and review what we talked about yesterday. Yesterday we talked about how solar radiation from the 27 million degree sun is traveling the 93 million miles through space to hit Earth. And because of the curvature of the Earth, that radiation that is full of light and heat is spread out over larger spaces. Now it's the same amount of energy divided over a larger space, which means that here you would be experiencing the full force of the sun, whereas here you would be experiencing the force of the sun spread out and weakened. And what that tells us is that parts of the Earth are hotter in one place and cooler in another because of that curvature. So that leads us to the next idea: hot air and cold air. So because some parts are hotter and some parts are cooler, it gets a little bit complicated. Now here's the thing. We all live in one atmosphere. There's only really one air. But in different places, if the air molecules are behaving differently because of the temperature, that air is going to react differently. So down here I have some hot air molecules vibrating, and they're getting excited from that heat. And as they vibrate and they heat up, they expand and they spread out. And what that does is it creates low density. Low density just simply means that there's not a whole lot of air in a given space because all of that air is heating up and the molecules are spreading out. Now here in the cold air is actually experiencing high density. Now, in places where you have high density meeting low density, what's going to happen is that really dense compacted air is going to want to flow over to where there's space. It's going to want to move to fill in those gaps. So what ends up happening is air molecules start moving to fill in those gaps where the hot air has expanded. Now, when you get a wall of cold air meeting hot air, what that's called is it's actually called a front. And on weather channels, you'll see this. They'll draw like a long bar with some triangles on one side. And basically what that means is it's essentially like a wall of really dense, tightly packed air that's cooler moving towards a part of the atmosphere where the air is hotter and the molecules are more spread out. Now, to further explore this concept of high density and low density, I'm going to need some really, really important scientific tools: a pinwheel and a balloon. So the balloon right now is not full, but there is air inside that balloon. That air is actually experiencing low density because it can flow in and out of the balloon. But if I fill the balloon up, all of a sudden, I've got a balloon here that, and I can't zoom out anymore. I can zoom in, but not out. Okay, all right. I've got a balloon here that takes up space. Now, outside this is the exact same amount of space that the balloon has. However, here in this open air, I have low density. Inside the balloon, I have high density because I've forced all of that air into the balloon using the muscles in my lungs. When I open the valve here, at the end of the balloon, all of this high density air is going to want to flow to where there's low density. And to illustrate that, I've got the pinwheel to show you. So even though you couldn't see it, the air, as it traveled from the high density of the balloon towards the low density of the space around it, created wind. It created a force of air molecules that were expelled from the balloon so powerfully that it turned the pinwheel. So essentially what wind is it's when a high density area of the atmosphere starts flowing towards a low density area of the atmosphere. Now, before we go much further, I do want to let you know that some people, when they're talking about wind and weather and the atmosphere in terms of high density versus low density, they'll use another term. Instead of density, they'll say pressure. So you might hear low pressure and you might hear high pressure being used. And that's basically the same concept, except that pressure simply has to do with the force of gravity on all of these air molecules pulling towards the earth. So it's hard to believe, but the atmosphere actually does have weight. And that weight is measured in terms of its pressure. And I believe the most common pressure measurement is pounds per square inch, or PSI. But let's go further and let's actually look at how this works to create wind in our environment. So when we have the sun heating up the land and the water, we experience this very, very differently depending on time of day and also geographical location, as we learned in the last video. One thing that I want you to understand is water is very hard to heat up. In fact, there's a famous saying that says, a watched pot never boils. And that's basically saying it takes a long time for water to get warm. And when all you've got is solar radiation, not necessarily a water in a frying pan or a pot over a fire, it's going to take even longer to get hot. So water takes a long, long time to heat up. But land is very easy to heat up. So what happens is the air over the water does not heat up as fast as the air over the land. So the air over the land gets hot and starts rising because hot air will always rise. Well, as it rises, it's going to start cooling off, and because it's cooling off, it's going to get less dense and it's going to start moving this way. And then once it's out over the ocean, it's going to start cooling off, and that air is going to start dropping. Eventually, it's going to drop some more. And then it's going to get so cool that the air molecules are going to condense a little bit. It's going to get tighter, and that pressure is going to build up. So it's going to start trying to move this way to fill in the low pressure, the low density, hotter air over the land. And essentially what happens is we've got air that's heating up, cooling off as it rises, moving over the ocean. As it's cooling, it's condensing and dropping. And because it's cooler, it's moving in to fill in those gaps over the less dense, less pressure land area. And what happens is you experience wind that's coming from the ocean to the land. And that's my sketch for wind. I don't know. It's from old cartoons, I imagine. What this is called a sea breeze. And I'm going to run out of room. Nope, I got it. Okay. A sea breeze is just simply when the cooler air over the ocean is blowing onto the land because of that change in temperature and that change in density. Well, the same thing actually happens at night, but in reverse. Like I said, water is hard to heat and land is easy to heat. Because water is so hard to heat, it also retains its heat. It keeps its heat for a little bit longer. But the sand actually, or the land actually loses heat pretty quickly. So at night, what happens is the air over the water is actually a little bit warmer than the air over the land. So if this land is cooler and more condensed and this land is warmer and more spread out, then what's going to happen is you're going to get some air molecules moving this way to fill in those gaps. And it's going to come this way and it's going to warm up. And because it's warming up, it's going to rise. And as it rises, it's going to spread out. And as it spreads out, it's going to cool off. And as it cools off, it's going to condense and get heavier. And as it condenses, it's going to spread out and lose pressure. Gain pressure. It's going to get more pressure and it's going to want to move to those areas of low pressure. And what happens in reverse is we now have the wind blowing this way. Okay. And what this is called a land breeze. So that is two ways that wind is experienced, and both of them have to do with air density or air pressure. That's it for today. We're going to look at a little bit more of this tomorrow and really explore what wind is.